The Java Secure Socket extension, known as JSSE, provides the core network and cryptographic services defined in the packages Java Security and Java.net. JSSE uses the same provider architecture defined in the Java Cryptography Architecture Framework, so updates to the JCA affect the JSEE as well. Oracle provides the Sun JSSE provider, which is registered with the JCA in the Java SE installation. Sun JSSE provides implementation of SSL, TLS, and its cipher suites, X509 key management, and private encryption keys in PKCS12 format. Java SE7 provided updates to its JSSE to fix a flaw which was discovered in the SSL TLS protocols in 2009. The flaw was in the TLS protocol itself, so it affected everyone using the secure protocol over the Internet. The IETF TLS working group developed a patch for this flaw, which has been implemented in Java SE7. Now, this attack exploits TLS's renegotiation feature, which allows a client and a server who already have a TLS connection to renegotiate to establish new parameters, generate new keys, or change the security level on the session. An example of renegotiation is a web server that allows anonymous client browsing, but then requires authentication or stronger encryption as more sensitive data is accessed, or peers with long-lived connections. They may renegotiate the connection periodically. Renegotiation is carried out on the existing TLS connection, with the new handshake packets being encrypted along with the other application packets. In the TLS renegotiation attack, the attacker piggybacks on an existing authenticated and encrypted TLS session. The difference between this attack and most man-in-the-middle attacks is that the attacker cannot read or alter the TLS session communication that are going on between the client and server. Instead, the attacker can prefix its own commands to the client communication to inject commands, downgrade a secure HTTPS session to a plain text HTTP one, or inject custom responses that appear to come from the server through exploiting the trace command. Since TLS is the base for other secure protocols, its vulnerability could be used to compromise secure SMTP and FTP communications as well. So you can see the TLS renegotiation attack has a broad impact on secure communication over the Internet. Java SE implemented its JSSE fix for the TLS renegotiation attack bug in 2 phases. First, in phase 1, it took away the ability to launch this attack at all by disabling the TLS renegotiation feature. Now, this was a quick emergency fix implemented in a critical patch released in March of 2010. Though renegotiation was disabled, it could be re-enabled by using system properties. The second phase implemented the IETF fix in RFC 5746. RFC 5746 adds additional TLS messages that cryptographically bind the TLS session to the client and allow the client to be informed about renegotiations. Since it would take time for all systems on the Internet to implement RFC 5746, the Sun JSSE provider was updated to allow 3 different modes, each specifying a different way to handle negotiations with a peer that has not implemented the IETF fix. Strict mode says both client and server must be upgraded to use IETF messages, or the handshake will fail and the connection will be terminated. Interoperable mode lets legacy TLS peers without the patch establish connections, but it does not allow renegotiation unless the peer has been upgraded with the IETF fix. Now, this allows the safest way to allow legacy applications to continue to operate until they have time to deploy the IETF RFC. Lastly, insecure mode allows renegotiation with no restrictions, leaving the system open to the original TLS renegotiation attack. The interoperable mode is the default one set in Java SE7, but you can change that with system properties. The system property sun.security.ssl allow unsafe renegotiations determines whether to permit legacy renegotiations. That's renegotiations with peers that have not upgraded to the IETF patch. This system property was introduced in Phase 1, where it could be used to re-enable the TLS renegotiation feature. The system property sun.security.ssl.allow legacy hello messages is used to allow legacy peers to handshake and establish connections without requiring the messages defined in the IETF RFC 5746. This property was introduced in Phase 2. Now, both properties are used to specify your application's operability mode. In strict mode, both properties are set to false. In an operable mode, the default mode, the unsafe renegotiation property is set to false, disabling renegotiation with legacy peers, but the allow legacy hello message is set to true, allowing legacy peers to establish connections. In insecure mode, both properties are set to true, thereby allowing any peer to renegotiate and leaving the system vulnerable to the TLS renegotiation attack. Java SE7 gave us a number of updates to the Java Secure Socket Extension, or JSSE. The Transport Layer Security, or TLS protocol, was updated from version TLS 1.0 to TLS 1.2. The new version has a number of new features, such as preventing the cipher block chaining attack, also known as the CBC attack. Other features include additional new cipher suites, a different hashing algorithm for internal use, and added flexibility in negotiating cryptographic algorithms. In hosted environments, a single server with only one network address hosts multiple virtual servers. Clients communicate with these virtual servers as if they were running on their own system. The server name indication, or SNI, is an extension to TLS described in RFC 4366. Now, SNI enables TLS clients to connect to virtual servers in hosted environments using a secure connection. This is because SNI provides a way for clients to tell the host server the name of the virtual server they are connecting to during the handshake. Now, using SNI, a host server can manage multiple certificates on a single IP address and TCP port, allowing client communication with multiple secure virtual servers, each with their own security credentials. Java SE7 added support for the SNI extension to the JSSE clients, enabling them to connect to virtual servers using a secure connection. Authentication decisions are determined on the combination of the X509 certificate and the locally accepted hash and signature algorithms. In connection-sensitive trust management, decisions on whether to authenticate the remote side can be done based on the hash and signature algorithms presented during the handshake. Java SE7 added new class X509 Extended Trust Manager to enable connection-sensitive trust management. With this new class, both trust managers and key managers can now examine the TLS connection parameters presented during the handshake. They can then use the credentials to determine if the hash and signature algorithms are acceptable for authenticating the remote side. This is done by calling the new getHandshake session method, which has been added to the classes SSL Session, SSL Socket, and SSL Engine. The getHandshake session method is used to retrieve the SSL session during the handshake before the session has been completely initialized. The new X509 Extended Trust Manager class can also verify that the identity it received in the in-entity X509 certificate matches the remote peer's address. This feature, used to prevent man-in-the-middle attacks, is accomplished with the check client trusted and check server trusted methods. The SSL session class represents the security context of an established SSL session. TSL version 1.2 added additional capability, which is represented in the new Extended SSL Session class. Extended SSL Session is a subclass of SSL Session, so it incorporates the SSL Session functionality, but adds methods to obtain the signature algorithm supported by the local and remote peers. The Java Control Panel is used to view and configure a number of the Java control parameters. Now, these parameters control how the browser works with rich internet applications, or RIAs. These RIAs include plugin applets, JavaX applications, Java Web Start applications, and any browser applications access to the native deployment toolkit plugins. Now, some of the many tasks you can perform with the Java Control Panel include managing certificates and exception site lists, setting runtime, debug, and applet handling options, and viewing and deleting the Java plugins temporary files. These functions are enabled by 5 tabs. Now, the tabs which were available in Java SE 6 include the General tab, which deals with identification, network settings, and temporary internet files. Then we have the Updates tab, which is available to administrators on the Windows and the Mac OS X platforms. The Updates tab works with the Java Update Scheduler to update the JREs installed on the system. The Java tab allows you to view and configure the Java runtime environment settings and choose the JRE, which will be used by the browser to run the RIAs. And the Advanced tab, which shows a long list of options for many areas. Just a few include debugging, Java console, secure execution environment, and application installation. Java SE 7 Update 51 added our very last tab, the Security tab, to provide additional control over RIAs. Now, RIAs are deployed as compiled client applications and installed as web browser plugins. RIAs run logic on the client machine, so they're offloading the server and giving very fast response time. But running unknown compiled applications on your system requires more security than the sandboxing provided. So this new Java Security tab gives us the ability to configure and control the security applied to rich internet applications. For extreme security, the Security tab can be used to prevent the browser from launching any Java browser applications you want to apply to the RIAs your browser will launch. The level very high requires a signed valid certificate with the permissions attribute in the main jar's manifest before the application will be allowed to run. And even then, a security prompt must first be okayed by the user. At level high, we have the same very high protections, but allow applications to run when the revocation status of the certificate can't be checked, still with a security prompt. And the medium level security allows all RIAs to run with security prompts. Now, Java SE 8 removed the medium level option. The site exception list is also managed from this tab. The site exception list holds the URLs of the rich internet applications we want to run on our system, which would normally be blocked by security checks. Adding these URLs to the site exception list gets them past the security checks. If an active deployment rule set is installed on the system, you can set deployment rules from the Security tab as well. Deployment rules enable a site to set up white and black lists for the RIAs running in their environment. Deployment rules hold the configured settings for different RIAs, determining if they can run without a security prompt, if they require a security prompt, or if they're completely blocked. The Restore Security Prompt button makes any previously hidden security prompt visible again. This option's there because some security prompts have that little checkbox that says, "Don't show this again." And it's a good idea to periodically turn all those prompts back on so you can evaluate if you really want them to be suppressed. You can always check for them to be suppressed again the next time they appear. And the Manage Certificates button brings up the certificates window, which allows you to list and configure the user and system certificates on your system. The different certificates you can manage include trusted certificates for trusted signed applets and applications, Signer CA or certificate authorities for those trusted certificates, certificates for secure sites, and the secure site CAs that are associated with the secure site certificates, and client authentication certificates, which clients use to authenticate themselves to a server. Now, users can export or get details about both the user and the system level certificates. But with the user level certificates, you also have the ability to import them or remove them from the system. I'm going to walk you through some of the new features of the Java Console Security tab. Now, in Java SE 7, you can start this Java control panel from the Windows Start menu. And you do it by clicking on the Programs, Java, Configure Java button. And we're going to do a quick overview of the Java SE 6 tabs that already existed before we look at the new Java SE 7 Security tab. First, we have this General tab here. And you can get version and identification information from About if you want to see what version you're running. This Network Setting tab lets you figure out how you want to connect to the internet. Now, it defaults to using the browser default proxy. But if you want to use a proxy server, you can configure that. You can use this automatic proxy server script. This is going to be the URL for a JavaScript file containing a find proxy for URL function. And that'll determine which proxy server to use. Or, of course, you can use a direct connection down here, which says there's no proxy needed. And then we have these temporary internet files with settings that let you manage the temporary internet files, including their location, the compression, and if you want to remove them or not. The Java tab here lets you see the settings the rich internet applications will be launched under. And here you can see I have two versions. I have both Java 8 and 7. Both are installed on my system. And I can click and modify any of these tabs if I want. I can enable them or disable them. I can remove some of them from being used in the browser, or I can find and add other ones. Now, I'm on Windows, and so the registry is going to say which Javas I have installed, so it's pretty easy for the console to find them. But if you were on some other systems, like some of the Unix systems, you might want to have to find where you had them installed in order to get rid of that, in order to tell the panel where they are to be able to use the other JREs. Now, quickly to the Advanced tab, you can see there's all kinds of things you can set in the Advanced tab. So you can go and play in there. But now let's go to the Security tab. This is the new tab. And first we have this checkbox, Enable Java Content in the Browser. You want to have this checked. If you don't have it checked, then no Java browser applications will be able to run at all. Now, once you let browser applications run, you have your security levels here, and it's in a slider. So high is the default. You can go up to very high or down to medium. If you have Java SE 8 installed, this is going to look different. You'll just have two checkboxes with the very high and the high option because the medium was removed. The medium option allows all rich internet applications to run with just a security prompt. They don't need to have certificates. And then you have the site exception list. Let's bring this up. This is where you add URLs of rich internet applications that we want to run on our system. These URLs are cleared. They don't have to go past the security checks. They'll just need you to OK them with a security prompt that'll pop up when you try to run them. And I don't have any active deployment rule sets installed. So I don't get the button here that lets me see the deployment rule options. You use the deployment rules to set up white and black lists for specific RIAs, rich internet applications. And the settings tell whether they're blocked or when they run, do they run with or without a security prompt. Now here's the restore security prompt. And this makes any previously hidden security prompts visible again. Then all the prompts that you said you wanted to hide in the future will no longer be hidden. They'll start popping up again if you say restore them all here. This might be something the security team might hit on all their users' systems periodically to ensure the users are forced to reevaluate if the prompt is important or not. And then the users will probably just go ahead, complain, and then turn the prompts off again when they see them. Lastly, we have this manage certificates. And this dialog is where we would manage both our user and our system certificates. Now, I don't have any certificates right now, but if I did, you'd see that on this user tab, all 4 of these buttons would be enabled. I'd be able to use all 4 of them to import, export, remove, or get details about my certificates. But when I go to the system, the only things that would be enabled would be the import and the details. I wouldn't be able to export or remove them. As time goes on, cryptographic algorithms, which we widely used and relied upon, are finally broken and classified as weak. But those algorithms are buried in lots of system security code that use them, and they're hard to replace. The JSSE 7 release supports disabling specific cryptographic algorithms used for certification path processing and TLS handshaking. This is done with 2 new security properties that hold a list of cryptographic algorithms that you do not want used, as well as the minimum acceptable key size. The security property jdk.certpath.disableAlgorithms holds a list of the restricted algorithms that apply to certification path processing. These are the algorithms used in certificates, revocation information, and signed OCSP, or Online Certificate Status Protocol Response. The algorithms are declared in a comma-separated list, followed by any constraints. Now currently, the only constraint is the key size constraint, used to specify the minimum number of bits allowed in a valid key. And the key size constraint is only used in key-based algorithms. The security property jdk.tls.disableAlgorithms holds a list of the restricted algorithms that apply to the SSL TLS protocol processing. These algorithms are used during SSL TLS security parameter negotiations involving versions, cipher suite selection, peer authentication, and the process for exchanging keys. This security property overrides anything explicitly coded in your application. So even if an algorithm is explicitly enabled in the application, it will still not be used in SSL TLS negotiation if it's listed in this property. Now, these are security properties, not system properties. Security properties can be set statically in the java.security property file that's found in the java home.ly security directory. And the Java home is your JRE installation directory. Or you can set them dynamically by calling the method setProperty on the security class in the Java security package. And you do this from your code. We're going to take a look at these new security properties that JSSE 7 gives us to disable cryptographic algorithms used for certification path processing and TLS handshaking. And we're here in our Java securities directory. Java Home, here's the installation directory for my JRE. Java Home is the installation directory for my JRE. And you can see here we're in the JDK 1.7.0, blah, blah, blah. And here's the JRE. And then you go to the live and security. So we're right here. And there's a lot of interesting files in here. The CA cert is the certificate authority, or the CA key store for the system. And we can be looking here at the Java securities file, which holds the security properties for our system. And that's here. We're in the Java security file. Let's go back to the top. And this file has a lot of good information in it. I can see line 6. This is where you go to configure the cryptographic architecture framework security providers. And we're going to go all the way to the bottom. And you can see there's lots of stuff in here, lots of security providers and lots of comments. If you get some time, you might want to go through it. You'll learn a lot about security. So if I go all the way down here, here's where it starts. This is where the cert path comment starts for the JDK cert path disable algorithms. And it explains the syntax, what it's for, and some stuff about it. And then finally down here, we finally get the property. Now this property here, JDK cert path disable algorithms. This holds the algorithms we do not want to allow to be used for certification path processing. And notice the algorithms here are separated by commas. But there's no comma between this constraint key size and the algorithms. That's because if you go up here to the syntax, you can see the disable algorithms. There's the syntax for it. You have an algorithm and a comma. And then if you have another algorithm, you have another comma and so forth. But down here, this is the constraint. The only constraint we have is a key size constraint. And the key size constraint has the key size, the operator, and the decimal integer. And the key size is the keyword. Here's the operator, and of course, the integer. So going back to here, this says that MD2 and RSA are the two algorithms that we're not going to be allowed to use for our certification path processing. And the key size, the minimum key size that we will accept is got to be greater than 1024 or greater. And this key size is only valid for algorithms that use keys. You could actually have had a key size that was a less than and a greater than. You can put a couple of key sizes there to get a range if you want. Now, some of the information up here, like here on 387, it says matching is performed using case-insensitive sub-element matching rules. So one, it's case-insensitive, but what's that sub-element matching rule mean? Well, if you go down to 392, it says the algorithm name will disable all certificate algorithms that rely on it. So here it's saying adding DSA will disable all the certificate algorithms that rely on it, including none with DSA, SA1 with DSA. But it doesn't, if you use DSA, it's not going to disable ECDSA. That's because this ECDSA, or elliptic curve digital signature algorithm, though it's a variant of DSA, it's its own algorithm. It's not a sub-element. So if you want to add another algorithm down here, you would put in a comma and then the algorithm name. And then that algorithm would be disabled from certification path processing. Now, something else to notice here. It says the property is currently used by this Oracle PKIX implementation. The Oracle PKIX is the security provider, and it's part of the Java cryptographic architecture. PKIX, Public Key Infrastructure for X.509 certificates, is an IETF standard used for building and validating X509 certificate paths. And this is saying that Oracle has put this PKIX provider in. When it's being used, this property will be used. But if you go in and you specify a different provider, security provider, instead of Oracle's PKIX provider, then you're not guaranteed for this property to be used or even read. Now, if I scroll down some more here, this is the algorithm down here for the property that the JDK TLS disable algorithm. This is our other system property that holds restricted algorithms that apply to the TLS handshaking. Now, from the example here, you can see that it takes exactly the same format as the cert path disable algorithm property we just looked at. But something interesting about it, you can see that the algorithms will be restricted from PKI, or public key infrastructure based peer authorization and key exchange. So any algorithms that we specify down here are going to be in addition to the algorithms that are specified up here for the cert path. So this cert path will get these algorithms and this algorithm as well. All those will be restricted. And just like above, it says the property is currently used by Oracle's JSSE implementation. Well, that's the Sun JSSE security provider. That's also used with that cryptography architecture framework. So as long as you stay with what is already defaulted and implemented in the JSSE, this property will be used. However, if you use the cryptographic architecture framework to specify a different security provider for TLS, then it's not guaranteed to use this property.